All right, so today's lesson is on similar figures. Please go back and watch the proportional or proportions lesson if you haven't already done so. This is the second lesson for today. Today what we're going to do is we're going to set up and solve proportions to find the missing measures of figures. So that's what we're really looking at today. And I'm going to go pretty speedy on this, so I'm going to have you pause and work out problems. And if I'm going too fast, you can always pause and back it up. If you need me to, because I'm not going to stay for prolonged times on slides. All right, so let's go ahead and talk about our lesson. So whenever we have similar polygons just means a many-sided shape. What we're going to end up is polygons are the same. Let me go get the right pen. The same shape, but they're going to be different sizes. Kind of like Alice in the Wonderland, when she eats the cookie or drinks the drink, she either grows or gets smaller based off of each one. The same idea goes along with a map, with a scale drawing, like in architectural designs, or when you're building a rocket, like a model rocket. There's no way that you can build the actual size, but you can build a custom model or a scale model. And that's what we're going to talk about today, but with just shapes. So polygons are similar if their corresponding angles are congruent. Now remember, you do need to have this in your paper notes or in your digital notes, one or the other. We went ahead and moved over this lesson the other day. We didn't get that far with it. The next one is corresponding sides are proportional. Now the ratio of the corresponding sides, that's called scale factor. Okay, and the polygons are similar if their perimeters are also proportional. So at this time, I would like you to go ahead and pause the video once I have everything written down, and go ahead and finish up your notes, and then play when you're ready to move on. Now, looking at scale factor. Scale factor does talk about it's basically what the ratios of the two sides are, or the ratio of corresponding sides. So when we're looking at that, and we're looking for the scale factor, I'm going to change to blue, of triangle ABC. So A to B to C, this triangle right here, to triangle D to E to F. Oh goodness. All right. So we're looking for that scale. Now I'm going to pick one side, so AB, which is 8. The next corresponding, and we talked about this in a lesson a few last week, or the week before Thanksgiving. So that's going to be 8 to 12, because 12 is going to be corresponding to that side. Now I can't leave it like that. I can go ahead and simplify it, and I would simplify that to 2/3. So that ratio would just be 2/3. Always simplify your ratios. Now let's go ahead and take a look. I'm going to erase all of this wonderful goodiness and change colors to green if we're looking at triangle DEF. So this triangle DEF to ABC. We need to find the scale factor from this triangle to this triangle. When we talk about order, it does matter. So when I start off with this triangle, I can pick 15. And if I pick 15, the corresponding side, which is EF, E to F, which are the second to the last, we need B to C right here. So that's going to end up giving us 15 divided by 10. Now I need to think to myself, what can I divide out of 15 and 10? I can divide out of 5. And that's going to simplify down to 3/2. All right, so my scale factor is 3 divided by 2. Let's go ahead and take a look at the ratio of the perimeters of triangle DEF and triangle ABC. I'm going to go ahead and switch colors. Let's go for purplish pink. Okay, so now we're looking at the ratio of perimeters. When we talk about perimeters, that's the sides added up. So I'm going to have to add 18 or 8. Sorry, hold on. Let me go back to the question. It says, what is the ratio of the perimeters of DEF and ABC? So when we're looking for the triangle DEF, we would add all of the sides together. So that would end up being 12 plus 15 plus 21. And that's going to give me a perimeter of 48. And then for the other triangle, we have 8 plus 10, which is 18, plus 20, or plus 14, which is going to give me 32. So that's the perimeter for ABC, triangle ABC. So because it talked about this triangle first, it's going to end up being 48 divided by 32. And the next step is we're going to go ahead and simplify that as far as we can go. Now 48 and 32 I know is divisible by 2, but I also can see that it's divisible by 8. So if I divide out an 8 from both of those, I would end up with 6/4. Now I can continue to divide them out because they're both even, so that would be 3/2, which notice how the perimeters of the same triangle relationship is going to be the same. And that's part of our notes from the beginning when we talked about the perimeters are also proportional. So that's exactly what we're talking about here when we look at the math. So the ratio or the scale factor between those two figures is going to be 3/2. All right, let's go ahead and take a look at our similarity statement. I'm going to pause here for a second. All right, when we're talking about similarity statements, a valid similarity statement must match the corresponding angles and sides. We've done this before with congruency statements, but this is a similarity, so we're making the statement that these two triangles are similar to each other, so it does look a little different. So it's asking us to write a statement for the triangles above. Now, I included these symbols down here for you to go ahead and copy and paste if you're on your computer. If not, if you're on your writing this out on paper, please make sure you have the diagram of the two triangles included on your notes as well. All right, so our statement is, as far as writing it out, we're going to start off with this first smaller triangle, okay? So we're going to just make the statement that triangle A, B, C, A to B to C is going to be similar. This is the similarity statement that you do need to use, okay? It's right here. Because if we use this, that means it's congruent or equal to, which that is not the case here. And then the next triangle, so if we start off, the corresponding parts of that triangle are going to end up being triangle DEF. All right, and that would be our similarity statement. Okay, let's go ahead and take a look at our first example. So for our first example, we're going to write all the congruent angles and we're going to write a proportion that relates the corresponding sides. Okay, so when we do that, we're going to end up with, and this is our congruency statement, so this helps us, our similarity statement. So it's going to start off with, we can say the first angle is congruent to the second angle, or angle J is congruent to angle P. So J is congruent to angle P. Now notice how the diagrams are totally off and they don't even look the same. So don't look at the similarity statements, don't look at the diagrams, but look at the actual similarity statements. Okay, so for the next one, we're going to go ahead and take a look at the second letter, which is going to be K and M. So we have K and M, and those angle K is going to be congruent to angle M, because mathematically they are congruent. Now, the last one is going to be L is congruent to N. And then when we're talking about sides, we need to, the sides themselves, the ratios of the sides are going to be congruent to each other. All right. So notice how I kind of drew a little bit of each one has a different shape, okay? And the angles can help us out here. So if I start with J, side J, and I'm going to change color here, maybe to blue or purple. No, that's too close. Red or blue. If I can get my colors right, goodness gracious. So from J to K, the corresponding side length is going to be in the denominator. Okay, so from circle to box, JK is going to end up whatever divided by, because it's the ratios of the sides, that's going to be PM. It's going to be equal to, whoop, I'm just going to keep going in the same direction here. So we end up having KL divided by MN. And we're going to do some math on this so that you guys can see this. And then that's going to be equal to our last, which is LJ divided by NP. There you go. Okay, so I want you to do the next one on your own, and then you can go ahead and check your answers with me. So now is a good time to pause the video, and we're going to go ahead and take a look at the next one. All right, so here are the answers for this next one. I just have to note that, notice how your angle Y is the second angle in the first triangle. It's also the second angle in the second triangle. So that angle is congruent to itself. It's a reflective property. All right, double check your answers, see if that's correct. If you have any questions, I can answer them on the following Tuesday. You can pause, go back. We're going to take a look at number 4 and set up a few of these ratios and how to solve them. So we've got about 5 problems left. Now when we're setting this up, if a figure below or similar with a scale factor of 2/3, so that's our scale factor, we need to find the value of x. So we know our scale factor is 2 to 3. Now with this worksheet, we're working from smaller to larger or left to right always, okay? And remember, order does matter. So our first ratio is 2/3, okay? And then our second ratio is going to end up being the side lengths. So we end up having 42 and x. So we're going to start with 42 in the numerator, divided by x, and now we're just going to solve it using a proportional relationship. So that's 2 times x equals 3 times 42, which is 3 times 42, which is going to end up giving us 2x equals 126. Divide by 2, that's going to give us 63. All right. So that's the ratio for number 4, and then for the other 4 problems, go ahead and work those out and set them up. Number 8 is going to be a little bit of a challenge, but I'm going to have the answer for you written out, and I'm going to show you that in the video, and you'll have to pause. Okay, here we go, and then have a great day, and I'll see you guys next Tuesday. All right, so with our similarity statements, if I start off with the angle the angle X, okay, I need to look for also the first angle, which is going to be congruent, which should be R. You actually do not need to look at the figure when you have a similarity statement for angles. So we have X and R. So X and R are going to be congruent to each other. Okay, now the next one we have is Y and Y. That looks crazy, right? But the real thing is that it's overlapping on top of each other, so it's actually going to end up being a reflective angle on top of each other. So angle Y equals angle Y, and that is a statement we do have to make. Now our last angle, which would be angle Z, is congruent to angle S. So angle Z is congruent to angle S. All right, now we're going to go ahead and take a look at sides. So when we're talking about the ratio of the side lengths, Teddy, can you give me one side length? Teddy, can you give me one side length? Just any side length.
What do you mean?
Give me any two letters on a triangle.
ZY.
All right, so if we're looking at Z all the way to Y, that's this one right here. So we have Z to Y divided by, so we're going to start off with ZY. What's corresponding to ZY on the other triangle? So we have the last letter to the middle letter. So what's the last letter to the middle letter on the other triangle? Teddy, if you're talking, you're muted.
FY.
SY. Okay, so then we're going to end up with SY as our denominator. All right. Oh, I know you're here. I'm sorry, Natalie. Natalie, do you want to answer your check-in question as far as what do you do when you're stressed? I apologize.
Oh, it's fine. I just wanted to make sure you knew I was here and you didn't count me absent.
No, I didn't count you absent. I'm sorry. I think I went ahead and pressed that you were here and then forgot to go back to you. I apologize.
Okay, I just wanted to make sure.
No, thank you for checking in. Hey, Natalie, can you help me out as far as what's the next side relationship here that
Sure.
we can make? Okay.
So would it be like S Y?
Because we started with X Y or ZY, this is going to be our numerator. So that's going to be on top and this is going to be on bottom. So this is the first and the second.
Oh, okay.
Okay. So can you give me another side on that first triangle?
Yeah. So XZ.
XZ, I like it. So if we have XZ, what would that corresponding side be on the other triangle?
RS.
Yeah. And that's going to be equal to, can you give me the last one?
Yeah. XY.
XY. Perfect. So that's going to be the first and the second. First and second of the second triangle is?
RY.
Yeah. And there we go. We've got our three relationship sides, our ratios. And when we have numbers, those are all going to simplify to the same exact ratio. All right. Let's go ahead and take a look at the third example. Just kidding, the fourth example. Using similar figures to solve for missing measures. And now what we're going to do is we're going to actually set up a proportional relationship and solve for x. So if the figures below are similar with a scale factor of 2/3, we need to find the value of x. So remember when we talked about order matters? Order does matter here. So 2/3 is left to right. We're going left to right on this worksheet from the smaller figure to the larger figure. And now it could be a larger figure to a smaller figure. Okay, that's what we would do on that problem. Okay, but on number 4, our first ratio that they tell us is going to be 2/3. We're going to set that equal to the relationship that we have here, which is going to be 42 divided by x. Now it's set up in a way that we can go ahead and solve for x. I'm going to look at the chat here in a second, and if I need to go back, I will. Go away. All right, so what I would do next is I'm going to go ahead and cross multiply, and that's going to be 3 times 42 equals 2 times x. And 3 times 42 is just going to give us 126 equals 2x. Divide by 2. And that's going to end up giving us 63 equals x. So that's a way we can solve for a missing side. Oh, good job, Victoria. Yep, so 63 equals x, and we can find missing side lengths when we're looking for proportional relationships. Now the cool thing about this is, this could be a map, and there's your scale. And you can find the distance between you and someone else by setting up a proportional relationship. So these do have real world applications outside of just figuring out similar figures. Okay, does anybody need to see this a little bit longer? All right, so let's go ahead and take a look at example 5. Example 5, I'm going to go ahead and pause, and I would like you to go ahead and solve this out. Okay, so if the figure below are similar with a scale factor of 6 to 5, you need to find the value of x. So I'm going to go ahead and stop here for a second and let you guys work this out for a minute or two. So you have 6 divided by 5. Whoa, computer, stop messing around with me. 6 over 5 equals,
28 over x.
watch out, you have to go left to right. And you can see by your ratio that this is going to be large and small. So this is our large and our small. So how would you change that ratio? Because we put large divided by small. So over here we need large divided by small as well. There you go. That's going to change your answer just a little bit. So would you like to continue on with a calculator, or do you want, would you like to pass it off to someone else? Yeah, that sounds fine. Can we maybe pick someone who's not an imposter?
Yeah.
Jack, go for it. What would we do next?
Me?
Yeah.
Okay, actually haven't gotten that far of the problem yet, but cross multiply.
Okay. Do you have a calculator handy?
My Siri, yes.
Oh,
My
Lord.
phone has a tapping glitch.
Okay, so from here we're going to have 6 times 28, which is 168 equals 5x. And then we're going to go ahead and divide both sides by 5. Okay, so once we divide that by 5, we're left with 33.6 equals x. Any questions on that before we move on?
Man based on innocent.
Okay. So looking at number 6, this one's a little different because they don't tell us a ratio between the two sides, or two polygons. But we do know the similarity statement. They tell us it is similar, and we can find the value of x. So if I start off with looking at a and b, so a to b is going to be x. Can anybody tell me the side that is corresponding or related to AB on the other triangle? Go for it, Julian.
DE.
DE, because it's the first and second letter. Okay, so D to E. So that's going to be x divided by 25. Now that leaves us with 28, which is BC, and we need to find EF, which is 20. Okay, so we're always going to start in the same direction. So if I went from x divided by 25, I'm going to go 20. I think my computer had a heart attack there for a second. X to 25 and 28 divided by 20. 28 divided by 20. Okay, so now that you have that proportional relationship set up, okay, Teddy, what would we do next to solve for x?
You would. What's the term?
Cross multiply?
Yeah.
Yeah. Go ahead and tell me what I would write down after you cross multiply.
20x is equal to 25 times 28.
Yeah. Okay, do you have a calculator handy? You should.
I have the app in the open.
Cool. Hey, Victoria. Do you have something to add? 35. Uh-oh, did we write some? Oh, you're answering the question. Okay, 25 times 28 is going to give us 700. And then go ahead and take 700 and divide by 20, okay?
35.
Perfect. And Victoria called it. Okay, so it is going to be x equals 35. What questions do you have on this problem before we move on? All right, anybody need that up a little bit longer? Because the only person I can see is Alexa. Alexa? Goodness gracious. The only person I can see in my class is Alyssa, and she's just kind of like, yeah, I'm good. But I can't see you guys, and I can't see if you guys are still writing. So if you guys are like about ready to flip the computer because I'm too fast, speak. All right, take a look at number 7. With number 7, we do have similar figures to solve for some missing measures. Oh, goodness. Okay. So what we're going to do first is set up a proportional relationship. And the way that we're going to do that is I'm going to ask on Caleb. Caleb. Yes. Okay. So looking at, they tell us the proportional or the similarity statement here. If I start off with 75, which is PS, what's corresponding to PS? Mm-hmm.
Oh, WZ.
Yeah, so if we take a look at WZ, that would be this one. So there's our first ratio, which would be 75 divided by 40 equals, okay, and then what about the next ratio? What would that be? So we have x over 32, yep. Okay, and then go ahead and solve it. What would it be? Oh my gosh, what do I keep doing that does that? It needs to lock. I do not want to zoom, my friend. All right, so in order to solve it, because I'm not sure what's going on the other side with Caleb, we're going to take 75 and multiply it by 32 equals 40x. Okay, when I multiply that out, that's 2,400 equals 40x. And then we're going to go ahead and divide both sides by 40, and we're left with 60 equals x. All right, very good job, Teddy. I saw you put that in the comments. Okay, any questions on this problem before we move on? All right, we're going to go ahead and take a look at our last problem. Dun, da, da, da. Here we go. Okay, so we have our similarity statement. Triangle AGM is similar to triangle KXD. We need to just find the value of x. This one's a little different. Remember, whenever we have two terms, we can rewrite them with parentheses. So can I have a volunteer on how to set this one up? Because it is just like all of the others we've done. The only difference is the added difficulty of the two terms. Okay, so when we are looking for the two sides, we could start off with Victoria. Is there a way you can unmute? Does it work or is it not working? Because we have AG, which is going to give us 32. And if I take KX, which is going to be our corresponding side, K to X, that's going to end up being X plus 3. So it's going to end up being 32 divided by X plus 3 equals, okay, here's our other relationship, JM, so our GM, which is second to last letter. Second to last letter is XD. So that's going to give us X plus 6. So that's 36 divided by X plus 6. And we're going to go ahead and cross multiply. So that's going to end up giving us 32 times X plus 6 equals 36 X plus 3. Okay, and now what we have to do is we need to go ahead and distribute the 36 and the 32 to both terms on the inside. So this is going to end up giving you 32x plus 36 times 6. or 32 times 6, which is 192. And then 36x plus 108, because I distributed the 36 to 3. Now when I want to solve for this, I need to go ahead and move over the smaller coefficient. So I'm going to go ahead and subtract 32x from both terms. This is going to become 0. I'm left with 192 equals 36 minus 32, which is just 4x, plus 108. Next step, I'm going to go ahead and subtract the 108. So that's 192 minus 108, which is just going to give us 84 equals 4x. Divide that with 4, which is just 21 equals x. All right, 21 equals x is our final answer. What questions do you have overall?